Welcome to EDU World Space.
So in this video, we're going to work through question 96 from chapter 20, which says molten CaCl2 is electrolyzed for 8 hours to produce solid calcium and gaseous chlorine. A, what current is needed to produce 5.52 kilograms of calcium metal? And B, if 5.52 kilograms calcium metal is produced, what mass in kilograms of Cl2 is produced? So we have our reaction, which is CaCl2 forming solid Ca and gaseous Cl2, but we can break that into half reactions. So we know that in our ionic compound, calcium has a +2 charge, and it's being turned into neutral, no charge calcium, just solid metal. So Ca +2 to Ca, that means we gain 2 electrons. So our half reaction is Ca +2 electrons yields Ca. And then for our other half reaction, we know that chlorine in this ionic compound takes a -1 charge and that we have 2 of them per CaCl2. So we have 2 Cl- being turned into Cl2, and in order for our charges to be balanced, we need 2 electrons to do that. So the overall half reaction is 2 Cl- yields Cl2 plus 2 electrons. So in our reduction half reaction, calcium is reduced from an oxidation state of +2 to 0, and in our oxidation half reaction, chlorine is oxidized from an oxidation state of -1 to 0. So it's important to note the number of electrons that are involved in this half reaction. So for every mole of chlorine gas that we produce, we are using 2 electrons, and for every mole of calcium solid that we produce, we're using 2 electrons. So it's important to keep in mind that factor of 2. So how do we calculate our number of moles of calcium? Well, we take the mass, the 5.52 kilograms, and we divide it by the molar mass of calcium, and we also multiply by 1,000 since there are 1,000 grams in every kilogram. You should check that your units work out, that you get moles when you do this, but the answer is 137.727 moles. And then how many moles of electrons do we consume as we form that many moles of calcium? Well, we know we consume 2 moles of electrons for every 1 mole of calcium we produce. So we just take that number and we multiply it by 2. So we're consuming 275.5 moles of electrons. And how can we convert that into a unit that will allow us to determine how many amperes of electricity we need to provide? So first we're going to convert moles of electrons to coulombs. So 1 mole of electrons is equal to 96,500 coulombs. So that gives us 2.66 times 10 to the 7th coulombs. And then coulombs are equal to the amperes that you're providing times the number of seconds that you're providing it for. And we're told that we're electrolyzing our molten CaCl2 for 8 hours. So 8 hours, 8 times 60 should give you 28,800 seconds. So the amperes that we have are equal to our coulombs divided by our seconds. So that gives us 923 amperes. So our first question in A was what current is needed to produce 5.52 kilograms of metal, and the answer is 923 amperes. In B, we're asked if 5.52 kilograms of calcium metal is produced, what mass in kilograms of Cl2 is produced? So we already calculated, based on our 5.52 kilograms of calcium metal, that we had 275.5 moles of electrons. So how many moles of chlorine do we have based on that? Well, we know that let's look at our half reactions again. We know that for every 1 mole of Cl2 we produce 2 moles of electrons. So if we have 275.5 moles of electrons, we just need to divide that by 2. And what we end up is 137.725 moles of Cl2. And to get the mass from the number of moles, we just take the number of moles and we multiply by the molar mass, which is 35.45 grams per mole. That gives us 4,882 grams, or 4.88 kilograms. So that's the mass of chlorine gas that we would produce.